So welcome to Geography MCQ discussion series. So we are in the 5th episode. Again, in this episode, we will be discussing the physical geography, world geography and Indian geography. All these questions will be based on the NCERT and even some applied questions. So this will cover the 1000 MCQs within 40 episodes. So we are in the 5th episode. Myself Tharun Kumar, author, Atlas Geography through Maps. Let's see the first question. Ganymede is the largest satellite associated with which of the following planet? Okay, so the question says Ganymede is the largest satellite in the solar system. So it belongs to which planet? Again, we have a option A, Saturn, B, Venus, C, Jupiter and D, Uranus. Let's see the discussion. So we know that Jupiter is the biggest planet in the solar system. Again, its satellite Ganymede is the largest satellite in the solar system. Okay, so correct option is Jupiter. So option C is the correct one. Next question. On which of the following planets is there a sea of hydrogen? Okay, so option A, Saturn, B, Mars, C, Jupiter and D, Neptune. Let's see the explanation. Again, we know that Jupiter is called as the failed star. Jupiter is called as the failed star. Why it is so? Again, we know that just like a star, its composition is also huge amount of hydrogen and helium. The stars are nothing but the self-illuminating objects. Why they are self-illuminating? Because of the thermonuclear fusion reaction occurring at their core. So because of the excess temperature, two molecules of hydrogen again converting and turning into helium. Though the Jupiter planet, it is also having the good amount of hydrogen and helium, but its internal temperature is not sufficient to support the thermonuclear fusion reaction. That's why, because of the excess pressure, the hydrogen, it is found in the Jupiter planet, it is turned into liquid one. Okay, so that is why we call it as the liquid hydrogen in the Jupiter as the sea of hydrogen. So planets sea of hydrogen, it refers to C, Jupiter. Okay. Next question. In which of the following planetary satellites can you find the most active volcano in the entire solar system? The question is very clear. Okay. So again, we have a good number of satellites to different planets. Except Mercury and Venus, we have all the planets in our solar system have the satellites. So within them, which is the most active volcano within the again entire solar system? We have a option A, Io, B, Moon, our Earth satellite, next Titan and D, Miranda. Let's see the explanation. See, this is the Io satellite belonging to Jupiter. Okay, so Io satellite is the highest active volcano. Highest volcanic activity is found on the Io satellite belonging to Jupiter. See, all these dots are found, you can see on the surface of the Io. These are mainly the volcanic eruptions, craters of the volcanic eruptions. So for this question, Io is the correct one. Okay, so Moon is a natural satellite of the Earth. Again, on the Moon surface also we can see the good number of volcanic eruptions. The dark patches what we see on the Moon's northern portion. So it is also because of the volcanic eruptions only. Again, Titan is a satellite belonging to Saturn. Again, we know that it is the only satellite to have a Earth-like atmosphere. And Miranda is a satellite belonging to Uranus. Okay. Next question. Consider the following sentences relating to the lithosphere. Okay. So the first statement states the top layer of the Earth's crust, and the mesosphere or the mantle togetherly called as the lithosphere. Okay. Next, generally the Earth has the three layers. The crust, mantle and core. Within the layers these are based on the chemical composition. Third statement is the density in these layers decreases from top to bottom. Let's again, these are the different layers found in the Earth crust. First, this portion we call it as the crust, and this one is the mesosphere or the mantle. The word mesosphere refers to middle one. Out of three, this one is in the center. That's why we call it as the mesosphere or even mantle. And this portion is completely the core region. Okay. So all these are based on the chemical composition only. So crust is having rich with the silica and aluminum content. Mesosphere majority is having again the within the crust, oceanic crust is having the silica and magnesium content. Even this mantle portion is rich with the also silica and magnesium, and even some good amount of the heavier elements or the radioactive elements like uranium, thorium, plutonium. But core is rich with the nickel and iron content. Okay. So all these are based on the chemical composition only. So the top layer of the earth crust and the mantle togetherly called as the lithosphere. Okay, so this statement says this portion. The word lithosphere refers to complete crust portion, and within the mantle we call the two layers, upper mantle and the lower mantle. So these two are togetherly called as the lithosphere. Okay, lithosphere. The hard solid surface of the earth is called as this lithosphere. Again, the temperature within these layers keeps on increasing from top to bottom. Within the crust, again, the average density is very less. So as we move to the every 32 meters, there is a gradual increase in the 1 degree Celsius temperature. So once we reach to the almost 70 kilometers depth, it will be almost 150 to 300 or 1500 degrees Celsius. Once we reach the mantle portion, it will be almost 3500 degrees Celsius. Once we reach the core region, it is up to 6000 degrees Celsius. So the temperature keeps on increasing from top to bottom. So here again, the top layer of the earth crust and the mesosphere or the mantle togetherly called as the, or the upper mantle, it is togetherly called as the lithosphere. So this statement is correct. Next, generally the earth has the three layers which are based on chemical composition, certainly silica, aluminum and magnesium. So silica, aluminum it is found in the crust portion, silica and magnesium it is found in the oceanic crust and even in the mantle portion, and finally nickel and iron content in the core region. So this statement is correct. Next, the density in these layers decreases from top to bottom. Temperature also increases, even the density also increases from top to bottom. So the density in these layers not decreases, it increases from top to bottom. As we can see in this region, here the density is almost 2.5 grams per cubic centimeter in the crust portion. In the mantle portion, it is 5.7 grams per cubic centimeter, and in the core region, it is up to 11.25 grams per cubic centimeter. So from top to bottom, the density keeps on increases. Okay. Even the temperature also increases, density also increases. So here the question is asking incorrect statement. We know that top layer of the earth crust and the mesosphere or the upper mantle togetherly called as the lithosphere. Should be here upper mantle. So togetherly called as the lithosphere. First statement is correct. The earth has three different layers based on chemical composition. Correct. The density in these layers not decreases, it increases. That's why third statement is wrong. So which of the above sentences is are incorrect? 1 and 2, B 2 and 3, C 3 only, and all of the above. We know that only C. Third statement is wrong. That's why this is correct. Let's go to next question. The Indian subcontinent was originally a part of which of the following land masses? Okay, so this question is related to the plate tectonics. Option A, Laurasia, B, Gondwana, C, India and Australia, and finally D, Aryavarta. Okay, let's see. See, we will discuss the continental drift theory. Okay, so this was proposed by a scientist called Alfred Wegener. Okay, so according to him, the present day all the continents were united together in a single continent. So that supercontinent he called it as the Pangaea. Okay, so within this Pangaea again he divided it into two blocks. North one as the Laurasia and southern one as the Gondwana. So as you can clearly see here, this is our Indian plate or Indian landmass. So it belongs to Gondwana. Okay. So option is B, Gondwana. Laurasia is the northern portion, present day North America and the European portions. So India and Australia, they belong to Gondwana portion. Aryavarta is the land portion within our India, the Indus Plain region or the Sindhu River Basin, where our Indus Valley civilization flourished. That place is called as the Aryavarta. Because according to good number of sources, we believe, or there is a statement that our Indus Valley civilization was started by the Aryans. So that way that place was called as the Aryavarta. Okay, but for this question, the correct option is B, Gondwana. Next question. Which of the following definitions is appropriate for a satellite? Okay. So first statement says, any celestial body orbiting another celestial body in the universe is called as satellite. Next. B. Satellites are those celestial bodies that revolve around the planets. Next. Only celestial bodies that revolve around the stars are called as satellites. And fourth one, D. None of the above. Let's see definition. First of all, the word satellite refers to. The simple definition according to NCERT is any celestial body which revolves around another celestial body is called as a satellite. So according to this definition, first example, our moon. It's a natural satellite of the earth revolving around the earth. Earth is a natural satellite for the star because it is revolving around the sun. Sun itself is a not constant. It is also revolving around the Milky Way galaxy. That means within our solar system or the galaxy or the universe, each and every celestial body is revolving around one another because each one of the celestial body falls within the gravitational influence of the another object. For moon, earth is the parent object because it is under the gravitational influence of the earth. For earth, sun is the parent object because earth is under the gravitational influence of the sun. For sun, Milky Way is the parent object because sun is under the gravitational influence of the Milky Way galaxy. So because of which for every 250 million years once it is going one revolution around the Milky Way galaxy. That we call it as the one cosmic year. So these are called as the natural satellites. But again, we also have a artificial satellites which are launched by the human beings for the study of the celestial bodies. Okay. So again, these are also under the gravitational influence of the earth for another. Even we launch it for the study of the other celestial bodies. Just like for the moon, we have sent the Chandrayaan-3 mission satellite. Okay. So according to the definition for our understanding, option A is the correct one. Any celestial body orbiting another celestial body in the universe is called as a satellite. Okay. So satellites are those celestial bodies that revolve around the planets, not necessarily. Okay. But why do we call them this as necessarily a satellite? Because according to definition, all the celestial bodies satisfy the satellite role. But to call it as a star, it should be self-illuminating object because of the thermonuclear fusion reaction and the emitting of the light and heat. But no other planets have the self-light light. Except the stars, no other celestial body is having the self-light. Even our moon also, it can be seen only because of the sunlight reflected from its surface. Okay. Even to call it as a planet, we have a 3 criteria. By default of the definition, all the celestial bodies follow or satisfy the satellite rule. But because of their nature only, we call them as the stars or a satellite or a dwarf planet or a meteoroid or an asteroid. Okay. So option A is the correct one. Next question. Which of the following sentences are correct with respect to earth crust? Okay. First statement says, it is made up of many small and large plates of the earth. The earth's crust upper layer is solid and the lower layer is liquid. Next, the earth's crust is thinner on continents and thicker at the bottom of the oceans. Next, the density of the earth's crust is higher on the continents and lower at the bottom of the oceans. Here the question is surrounding about the plates on the earth crust layers, then the continents, the earth crust thickness on the continents and the oceans, and even the density of the continents and the oceanic plates. Let's see the explanation. Here we know that earth crust, this crust portion, it is made up of the good number of small pieces. These are called as the plate tectonics. What are plate tectonics? These are the building blocks of the earth crust. Because of the word plate tectonic, it is derived from the Greek word builder. Builder, plate tectonic refers to builder. That means plate tectonics are the building blocks of the earth crust. Because of the accumulation of the smaller pieces which are floating on the astrosphere, they have made the earth's crust. Next, within the earth crust again, The second statement says the upper layer is solid. Within the earth crust, the upper layer is solid, and second one, it is saying that lower layer is liquid. No. The complete earth crust portion, it is completely solid, but not liquid. Its average depth is up to 70 kilometers. So it is completely a solid one, not necessarily liquid. Next, the earth's crust is thinner on continents and thicker at the bottom of the ocean. No. The earth crust is more thicker on the continents. Thicker on the continents, and on the bottom of the ocean it is very thinner. So this statement is again interchanged. Next, the density of the earth crust is higher on the continents and lower at the bottom of the ocean. Again, this is also interchanged. The density is more in the oceans because it is completely made up of the water. That's why density is more in the oceans and less in the continents. But the thickness is more on the continents and less in the bottom of the oceans. Okay. So, according to the question, so with respect to which of the sentence is correct? We know that it is made up of a small and large plates of the earth. So we call them as the plate tectonics. So earth crust upper layer is solid and lower layer is no. Second statement is wrong. First one is correct. The earth crust is thinner on the continents. This statement is also wrong again. Fourth one is also wrong. So only first statement is correct. That means option C is correct. Only first statement is correct. Next question. Which of the following sentences are incorrect? Okay. The earth's crust occupies hardly 1% of the earth layer. The mantle or the mesosphere is completely liquid and covers 85% of the earth's crust. Next, the mesosphere has the highest density. Let's see. This crust portion, it occupies hardly 1% of the volume. Among all the three layers, it is hardly 1%. So crust is completely solid. Be it upper layer or the lower layer, it is completely solid. When we come to mesosphere or the mantle again we call it as the two layers, upper mantle and the lower mantle. The upper mantle is again semi-solid. It is semi-solid, whereas the lower one is completely again solid. Core region is again, upper region is completely liquid, but this one is solid. So crust is topmost layer, it occupies hardly 1% of all the three layers. It is completely solid, be it upper or lower. When we come to the mesosphere again or the mantle, we call it as again it is divided into two layers, upper mantle and the lower mantle. Upper mantle is semi-solid in nature, whereas the lower one is again completely solid. When we come to core region, again this also we classify into two layers, upper core and the lower core. So upper core is again completely liquid, whereas the lower core is again completely solid because of the heavier elements like the radium, uranium, thorium and plutonium. The highest density is observed here, 11.25 grams per cubic centimeter. Okay, here it is hardly 5.7 grams per cubic centimeter. Within the crust it is hardly 2.5 to 6 grams per cubic centimeter. Okay. So here the earth crust occupies hardly 1% of the earth layer. This statement is correct. Next, the mantle or the mesosphere is completely liquid. No, only the upper mantle is semi-solid, whereas the lower one is semi-solid. So solid. Upper one and the lower mantle is solid. Upper one is semi-solid, lower one is just a solid. So again it contains 85% of the earth's crust, or it covers the 85% of the earth's layers. This statement is again wrong, but partially it is incorrect. The mesosphere has the highest density. No, core has the highest density of 11.25 grams per cubic centimeter, whereas the mesosphere or the middle mantle layer it is having hardly 5.7 grams per cubic centimeter. That's why only this statement is correct. This statement becomes wrong and third statement also becomes wrong. So here the question is asking which is incorrect statement. That means option A 1 and 2, B 2 and 3, C all are correct, D 3 only. So only 2 and 3 statements are incorrect. Next question. Who gave the continental drift theory? Okay. So again we have a option A, Abbe Georges Lemaitre, B, Immanuel Kant, C, Alfred Wegener, and D, Stephen Robin. Let's see the explanation. He is the person called Alfred Wegener. Okay. So he proposed the theory called continental drift. Okay. So what continental drift says, again, according to him, all the present day continents were united together, which he called it as the Pangea. Within the Pangea, he made the whole continent into supercontinent into two blocks, Laurasia and the Gondwana. Okay. So based on that, again we have a present day 7 continents. So for this question, who gave the continental drift theory? It is again option C, Alfred Wegener. Okay. Next question. Because of this, the plates of the earth are constantly in motion. We know that plates of the earth, plate tectonics of the earth crust are constantly in motion. What is the reason? Option A, we have the gravitational force of the sun and moon. B, the speed of the earth's daily rotation. C, convectional currents in the mantle. And D, all of the above. See, this is called as the convectional currents. The word convection refers to. So within physics, you might have read the conduction, convection, and radiation. Conduction, convection, and radiation. The word conduction refers to transfer of heat energy through touching. It is possible only in the solids. Okay. So when we boil the vessel, the upper surface, so the lower surface first becomes heat. Because of the transfer of the particles, the heat gets transferred from top to bottom layer. So that is called as the conduction. In case of convection, here this convection again transfer of heat energy through the movement of the particles, water particles or the air particles. It is possible only in the liquid and gases. Liquids and gases. It is possible only in the solid particles. So convection refers to movement of the or transfer of heat energy through movement of the air particles or the liquid particles. So when we boil the water, the water present in the bottom layer, it gets heated and again it rises vertically, so it transfers the heat energy. So similarly in the gases also, once there is a heavy temperature, the air particles which are in contact with the warm earth surface, they get warmer and they start to move vertically. This vertical movement of the heated air, we call it as the convectional currents. Similarly, this process also applies to the earth interior layer. Again we read that within the earth crust, again mantle portion. Okay, mantle portion, the upper mantle is semi-solid in nature. Semi-solid. So this is the upper mantle. Because of the excess temperature from the earth's core region, it is having the 6000 degree temperature. Because of the excess temperature, this semi-solid upper mantle, asthenosphere, it is constantly moving. The lithospheric plates which are found above this, they are constantly in motion because of the circular motion of this asthenosphere, which we call it as the convectional currents. The word current refers to mass movement of objects. If there is a mass movement of the ocean water, we call them as the ocean currents. If there is a mass movement of the wind, we call them as the air masses. If there is a mass movement of the air vertically rising, we call them as the convectional currents. So within the earth crust or within the earth interior region, the asthenosphere, it is continuously moving, which we call them as the convectional currents. So because of this only, the earth crust plate tectonics are constantly in motion. So option is C, convectional currents in mantle. What were the reasons given by the Alfred Wegener for the movement of the continents? Okay. So option 1 says the polar fleeing force, 2 the gravity of the sun and the moon, the rotation of the earth, convectional currents, and C, 5 ocean tides. Let's see. Again, Alfred Wegener, when he proposed the continental drift theory, okay, so he was not sure about the convectional currents. So he believed he has some own conclusions regarding the continental drift. So what were the reasons or the forces behind the movement of the continents? So first one, he said the gravitational influence of the sun and moon. As we know that the sun and moon have the gravitational influence on the earth. So because of their gravitational drag, they are dragging the continents in east and west direction. The second force, he said that polar fleeing force. Polar fleeing force. What is the meaning of polar fleeing force? We know that gravity is more near the polar areas, north and southern polar areas. Again, because they are very closer to the Earth's core region. So because of the more gravitational force near the polar areas, so the gravitational force is dragging the continents in the north-south direction. And gravity of the sun and moon, they are dragging the continents in the east-west direction. Again, the oceanic tides, they are also pushing the continents towards the outer side regions. So that is nothing but the buoyancy force. Buoyant force. When all these forces applied together constantly over a period of time on these continents, so they get separated. This was the assumption given by the Alfred Wegener. So first one, the polar fleeing force. Second one, the gravity of the sun and the moon. The rotation of the earth. So because of the rotation of the earth only, there were oceanic tides. So according to him, the continents were floating on the oceans. So once these tides are created, so the tides are pushing the continents to the other sides. Next, oceanic tides. Except fourth one, except the gravitational or the convectional currents, 1, 2, 3 and 5 are the assumptions given by the Alfred Wegener for the movement of the continents. So option A, we have 1 and 2, B 1, 2, 3 and 5, C 1, 2 and 5, and D all of the above. So except fourth one, 1, 2, 3 and 5, B is the correct one. Next question, which of the following sentences is are correct? First statement says, the astronosphere is the only liquid layer in the earth. Next, the upper core is completely semi-solid. Third statement says, for every 32 meter, as we move deep inside the earth, the temperature rises by 1 degree Celsius. Okay. So here the question is asking the astronosphere and its nature, the upper core region, and finally the temperature within the layers. So we know that earth is divided into 3 layers, the crust portion, the mantle portion and the core portion. Crust is completely solid, be it upper crust or the lower crust. Whereas the mantle portion, the upper one is semi-solid, whereas the lower one, it is completely solid. The only liquid layer is upper core, and the only complete solid layer is again core, lower core region. So to remember simply, within the crust, mantle and core, we know that crust is completely solid. Within the mantle, upper portion is semi-solid, lower one is again solid. Within the core region, upper core is liquid and the lower core is solid. Need not remember all this. Just remember the 2 exceptionals. First one in the order, mantle is the semi-solid one, upper mantle. Upper mantle is semi-solid and the upper core is liquid. Rest all are completely solid. Okay, so if you know these 2, it's correct. Clear. So the first statement says the astronosphere is the only liquid layer. No, astronosphere is the semi-solid layer. Only the upper core is liquid layer. That's why this statement becomes wrong. Next, the upper core is completely solid. No, upper core is completely liquid. This is the only layer which is completely liquid. So this statement is also wrong. Next, every 52 meter as we move deep inside the earth, temperature rises by 1 degree Celsius. No, every 32 meter for every 100 feet, 1 degree Celsius average because the pressure and the density also keeps on increasing. That's why temperature increases for every 32 meter. There is a 1 degree Celsius. So here it is telling 52 meters. That's why this is also incorrect. So here the question is asking which is correct statement. 1, 2, 3, all the three are wrong. Options we have A 1 only, B 2 and 3, C all of the above. That means all the statements are correct. Here it is, we have a D. None of the above statements are correct. So that's why option D is the correct. Next question. Which minerals are the highest in the Earth's mantle or the mesosphere? Let's see. Option A, silicon and iron. B, silicon and magnesium. C, nickel and iron content. D, carbon and nickel. Let's see the explanation. Okay. So within the crust, we know that Earth crust is made up of the silicon and aluminum, and the oceanic crust is rich with the silicon and magnesium. As it is very closer to the mantle portion, even the Earth's mantle portion is also rich with the silicon and magnesium content. Even it is also rich with the radioactive elements like radium, uranium, thorium and plutonium. What is the importance of these radioactive elements? So they are found in this mantle portion region. Because of the excess temperature, they melt and release the again excess heat. Because of their excess heat only, this semi-solid asthenosphere, it is constantly in motion, which we call it as the convectional currents. Okay. So we know that mesosphere, it is rich with the silica and magnesium. That's why the crust is called as the Cia layer, mesosphere is called as the Sima layer, and the core region is called as the Nephe. Core is rich with the nickel and iron content. That's why we call it as the Nephe. So option is B, silica and magnesium. Okay. Again, you might have read that silica and magnesium is rich in the oceanic crust. Again, we know that oceanic crust is very near to the mesosphere region or the upper mantle portion. That's why both are rich with the silicon and magnesium content. Even the mesosphere is also rich with the radium, uranium and thorium, plutonium. These are the radioactive elements. Should know. So option B is correct one. Next question. What is the temperature in the Earth's core? Okay, direct question. Option A, 1200 degrees Celsius. B, 3500 degrees Celsius. C, 5500 degrees Celsius. And D, 6000 degrees Celsius. Okay, let's see. So we know that on the Earth's surface, temperature is average 16 degrees Celsius. From equator towards the poles, if we take average, it is hardly 16 degrees the temperature. As we move deep inside the Earth, temperature keeps on increasing. Okay, so near the core region, it is up to 6000 degrees Celsius. Okay, such a high temperature. This high temperature is found on the sun surface. Such a high temperature is found in the Earth's interior region. Okay. So option D, 6000 degrees Celsius is the correct one. Next question. Who propounded the seafloor spreading theory? Okay, direct question. Option A, Hugo, Benioff. B, Professor Harry Hess. C, J. Morgan. And finally D, none. Let's see what is this seafloor spreading theory. Okay. So after the continental drift theory proposed by the Alfred Wegener, so this was proven wrongly because all the evidences given by the Alfred Wegener were correct, but the reasons behind the continental drift were wrong. Okay. So again, that continental drift theory, it was modified and proposed in the form of the plate tectonic theory by J. Morgan. J. Morgan. Shall see that later. Okay. So here is the seafloor spreading. What is the seafloor spreading? Again, now we came to know that plate tectonics. Okay, the Earth crust is made up of the good number of smaller pieces, which are technically called as the plate tectonics. So here, this is the African plate and this is the South American plate. Because of the convectional currents, these two plates are in divergent motion. They are getting separate. So because of the separation, there is a rift created within the Atlantic Ocean. So within this rift, there is a continuous volcanic eruption like this. Due to continuous volcanic eruptions, this lava, which is getting, which is rising vertically, due to continuous cooling and solidification, it is turning into a landmass. Once it turns into a landmass, it puts pressure on either side of the crust portion. So because of which the Atlantic Ocean floor is increasing. That means the young portion is found at the center and the old portion is at the periphery. This is called as the sea floor spreading. Okay. So this theory was proposed by scientist called Harry Hess. Okay. So he is the person called Harry Hess. He observed the sea floor spreading theory. After the continental drift theory disproven, these are the sea floor spreading theory and the Pacific ring of fire. These were proven. Based on that only, J. Morgan modified the continental drift theory and proposed the plate tectonic theory. Okay, so J. Morgan is the father of the plate tectonic theory. Again, it is a modified version of the continental drift theory only. Okay. Next question. Who wrote the book The Origin of the Continents and Oceans? Option A, Eratosthenes, B, Ptolemy, C, Alfred Wegener, and D, Mark Peter. Let's see the explanation. Okay. So, he is the person Alfred Wegener. Before proposing his theory, continental drift theory, he proposed this theory in his book called The Origin of the Continents and Oceans in the year 1916. He wrote this book, The Origin of the Continents and Oceans, to hypothesize or propose his theory, continental drift. Okay, so in the year 1960. So option A, we know that. C, Alfred Wegener, he was the author of The Origin of the Continents and Oceans. Next question. Which of the following is or an example of the large continental plate? Okay. Option 1, Pacific plate. B, second one, the African plate. C, Philippine plate. And D, fourth one, Arabian plate. Okay, let's see. See, this is the earth crust and these are the small pieces which are technically called as the plate tectonics, which are floating on the convectional currents. Okay. So, this plate tectonics, based on their size, we classify them as the major and minor. Major means very larger one, minor means very smaller in size. This is based on size. Again, based on the land portion or the water body found on them, we call them as the continental plate or the oceanic plate. Best example, here you can see the Pacific plate. So, on which the complete Pacific Ocean is occupied. So, we call them as the oceanic plate. Here is the Eurasian plate, completely made up of the Europe and Asia. So, on this plate, majority is the land portion. So, we call them as the continental plate. Okay. So, here you can see the Eurasian plate as the larger one, North American plate, South American plate, African plate, Indian plate, Eurasian plate. Again, recently we have identified the Fontic plate. Okay. So, Philippine plate is the again minor one, part of the Pacific plate only nearby. So, let's see this. So, Pacific plate is the larger one, African plate is the larger one, whereas the Philippine plate and the Arabian plates are the minor ones. Okay, here. Philippine plate is the minor one and even the Arabian plate is also a minor one. Rest all are major plates. So, larger plates are only two, Pacific plate and the African plate. Option A, 1 and 2, but not the 2 and 4. So, option A is the correct one. Next question. Which of the following sentences is are correct? Okay. The Pacific plate is the largest oceanic plate. The Eurasian plate is the largest continental plate. And the plate of India is a small plate which moves northwards. Okay, so it is talking about the Pacific plate, Eurasian plate and the Indian plate. As we discussed, Pacific plate is the largest plate. Irrespectively, size wise, Pacific plate is the largest plate. Again, it is covered with the oceanic body, so it is the largest oceanic plate. Whereas the Eurasia, continental plates, the plates on which the continents are formed or the land hemisphere is formed, we call them as the continental plates. So, Eurasian plate is the largest continental plate. Again, Indian plate is also a largest plate, but not a minor plate. So, it was found here, so it has moved in this direction, the northeast direction. So, after its convergence with the Eurasian plate only, we have a Himalayan mountains. So, Pacific plate is the largest oceanic plate, correct option. Eurasian plate is the largest continental plate, correct one. The plate of India is a small plate. No, it is also a largest one which moves in the northward direction. So, The question is asking correct statement. So only options we have 1 and 3, 2 only, 2 and 3, and D 1 and 2. Third statement is wrong, 1 and 2 are correct. So option D is the correct one. Next question. In which of the following ways are the plates of the earth are moving? Okay. So option says first one convergent, 2 divergent, 3 transforming, and 4 triple junction. Okay. So this is about the movements of the plate tectonics. We know that plate tectonics, they are under the continuous motion because of the convectional currents. Okay, so they are floating on the convectional currents. So in this case again, two plates, they can converge each other, or they may get separate each other, or they may move side by side. So convergent boundary, so when two plates meet each other. Divergent boundary, when two plates move apart each other. In transfer boundary, they will be moving parallelly. So apart from this again, there are chances where more than two plates also get converge each other. So in that case again, Pacific plate, it is having the continuous friction with the neighboring plates. So if this is the Pacific plate, it is getting converged with the North American plate, South American plate, here is the Australian plate, and here is the Eurasian plate. So we call them as the triple junction. That means where more than two plates are getting collided, or they are in the continuous friction. So here we have options convergent, divergent, transforming, and triple junction. Option only 1 and 2, B 2, 3, 4, C 1, 2, and 3. We know it is all of the above. Okay. So plates are converging, they are diverging, they are transforming. Again, there are chances where more than 2 to 3 plates are converging each other. So option D. Next question. Which of the following sentences is are incorrect? Okay, the question is demanding the incorrect statement. First statement says oceanic plates have a higher density than continental plates. Next, the Pacific plate is colliding with all the neighboring plates, as we discussed now. Next, the movement of the plates is 15 centimeters to 1.5 centimeters per year. Okay. So let's see. Oceanic plates are having the highest density than continental plates. So as the oceanic plates contain majority of the water body, so that's why density will be very higher in the oceanic plates compared to continental plates. So this statement is correct. Next one, the Pacific plate is colliding with all the neighboring plates. This is the Pacific plate. It is getting converged with the North American plate, South American plate, Australian plate, and the Eurasian plate. So that's why we call them as the Pacific ring of fire. As the plate is getting converged here, so it is getting subducted. Because of the more density, always the oceanic plates get subducted below the continental plates. Okay, so that's why it is created a good number of the volcanic islands or the volcanic eruptions here. So again, the movement of the plates will be from 15 centimeters per year to 1.5 centimeters per year. We know that our Indian plate, it was lying here, so it has moved in the northward direction, northeast direction. So initially when it was flowing in this region, oceanic plate region or the Tethys Sea region, so it was moving at a rate of 15 centimeters per year. Once it met with the Eurasian plate, so now its speed is hardly 1 centimeter per year. So because of the convergence of the Indian plate with the Eurasian plate, the Himalaya mountains are growing. The Himalaya mountains are growing at a rate of 1 centimeter per year. Indian plate is moving at a rate of 5 centimeter per year now. So Indian plate is moving at a 5 centimeter rate. Okay. So when they are moving individually, their speed will be very high. Once they meet with another plate, so their speed gets reduced. Okay. So in that case, first statement is correct. The Pacific plate is colliding with all the neighboring plates. This is also correct. So third statement is also correct. So option, the question is asking incorrect statement. So that means D, none of the above is incorrect. All the statements are correct. Next question, which of the following is an example of a small plate, small tectonic plate? Again, as we discussed, they are based on the size, we have a major and minor plates. Okay, let's see. First one, Fuji plate, 2 Philippines plate, 3 Carolina plate, and 4 Arabian plates. Which of the following are example for the minor plates or the small plates? Let's see. So this is the Caribbean plate. This is the Scotia plate, Arabian plate, Juan de Fuca plate, Cocos plate, Arabian plate, Philippines plate, Fuji plate, and Carolina plates all are example for the smaller plates only. Okay, so that means option D, all of the above is the correct one. Next question, what are the natural features observed when two continental plates meet? Okay, so when two continental plates meet each other, so what is the consequence or what is the resultant landform? You can see. Option 1 says trenches, 2 cracks or the faults, 3 mountain formation, and 4th earthquake, and D 5th one volcano. Okay, let's see what are all the. See, when two plates converge each other, the crust portion which is found on them, it keeps on folding. So because of which it creates the mountains. Himalaya mountains are best example for the unfolded mountains. Next, again, within their boundary region, due to continuous friction, there will be earthquakes. Even we can also witness the volcanic eruptions when one plate gets subducted below the other. Okay. Even the trenches can be seen here, faults can be seen along the boundary area. So that means trenches, cracks, faults, mountains, earthquakes, volcanoes, all this can be seen when two continental plates meet each other. So option A, 1, 2 and 5, B, 2, 3, 4 and 5, C, 3 and 4, and D, all of the above. So all the landforms or all the natural features can be seen. So option D is the correct one. Next question, the cause of the African Rift Valley. Okay, so option A says the plates of the Indian Africa are diverging. B, Namibian and the Nubian plates are diverging. The plates of the Africa and the Antarctica are converging. And D, plates of the Africa and the Eurasia are converging. So African Rift Valley is a major phenomena. Let's see. This portion, this part of the this portion is called as the African Rift Valley. This is how it is naturally seen. This plate is called as the Nubian plate, and this is called as the Namibian plate. Namibian plate. These two plates are moving in this direction. That's how there is a continuously long rift has been created, which we call it as the Great African Rift Valley. Okay, so it is because of the divergence of the Nubian plate and the Namibian plate. So in the near future, this portion gets separated and lies in the center part of the Indian Ocean. Around within the next future of the 350 to 300 to 350 million years, we can see one more island continent in the Indian Ocean region. This portion is getting separated. Okay. So according to options, we know that B, the divergence of the Namibian and the Nubian plates is causing the African Rift Valley. Okay, so option B. Next question, what is the reason for the spread of the sea floor? Okay, so as we discussed again, upwelling volcano, 2 convectional currents, 3 separation of the plates of the earth. Okay, let's see. Again, so 2 plates, African plate and the South American plates, they are getting separated. Again, there is a continuous volcanic eruption. That means the lava is spreading outside. So due to continuous volcanic eruptions, it is not reaching above the ocean surface. It is gradually upwelling. Just like a overheated milk comes from the vessel, it is just outpouring. As it is near the water body, so there is a continuous rapid cooling and solidification. Rapid cooling and solidification. So it is turning into a landform. After the turning into landform, it is pushing the older landform to the outside, and the young landform is getting prepared at the center. So this is called as the seafloor spreading. So options wise, upwelling volcano is there, convectional currents is there, and separation of the plates of the earth. 1 only, B, 1 and 3, all of the above, 2 and 3. So all the 3 are correct. So that's why C is the correct one. Last question. What is special about the Pacific Ring of Fire? Okay. So option A, minerals around the Pacific coast. B, cyclones originating from the Pacific coast. C, volcanic and seismic earthquakes along the Pacific coast. And D, atmosphere of the water on the Pacific coast. Okay. So as we discussed in the previous questions. See, this is the Pacific ocean. Okay, Pacific plate, boundary of the Pacific plate. As we discussed in the triple junction concept, The specific plate, it is continuously in colliding with or friction with the neighboring plates. North American plate, South American plate, Australian plate and the Eurasian plate. So due to continuous friction with the neighboring plates, there is a continuous subduction of this plate, so that is leading to volcanic eruptions. So the boundary of the Pacific coast is made up of the good number of volcanic islands. So this is popularly called as the Pacific Ring of Fire. This concept was given by scientist called Professor Hugo Benioff. He gave the concept of the Pacific Ring of Fire. So it is rich with the, or famous for the good number of volcanic eruptions, and even good number of the earthquakes can also be seen here. The Japan region, it is called as the land of disasters because it is highly prone to volcanic eruptions, earthquakes, tsunami, everything. So what is special about the Ring of Fire? We know volcanic and the seismic earthquakes along the Pacific coast. So option C is the correct one. Okay. So this is the end of this episode. We have completed the 25 questions. Hope you guys enjoying the series. For more updates, please subscribe for Uttar Academy channel. Okay, thank you.